Da 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 da. Da, 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 da. All right, today we are going to talk about how to calculate sample size. We want a 90% confidence interval, and we have our sigma here, which is 15,000 per year.
How do we know sigma?
Well, for right now, sigma is just magic. We just magically know that because you get told that, and at some point we will talk about it not being magic.
Okay, that makes sense.
And our goal is going to be to calculate the sample size we need to have a margin of error of 0.7 thousand per year.
Now wait a minute, what was margin of error again? I forgot.
So if you recall, for a confidence interval, we take x bar and we go plus or minus some z-score with a sigma over the square root of n. This piece is our margin of error. In other words, from x bar we add z sigma over square root of n, and that's how we get our upper bound. And we subtract z sigma over square root of n. That's how we get our lower bound.
So I could say the margin of error is my uncertainty around my estimate of x bar?
That's a great way to say it. Now, do keep in mind that if the question says I want a width of the confidence interval, that width is going to be 2 margins of error. So from lower to upper is 2 times the z sigma over square root of n. Our equation is going to be margin of error, which we sometimes call Mo because he hates that, equals z sigma over square root of n. And all we have to do is fill in these values. For our z, we have 1.645.
Now where did the 1.645 come from?
Okay. Well, if I draw the normal curve here, and I want to capture 90% in the middle, how much will I have on each tail?
0.1?
0.1 is not the correct answer because 0.1 plus 0.9 plus 0.1 is too much.
But I have 0.1 in total on the outside.
Both of these add up to 0.1.
Oh, okay. So then what's on the one side?
That's my question.
0.05.
That's it.
Oh, there we go. Got it.
Now, I'm going to put in 0.05, and there is the 1.645 for my z-score.
Now, do I use the negative? What is it, negative or positive?
That is an excellent question. Let's try both. So, for margin of error, why don't you fill in the value that we want our margin of error to be?
So I want the margin of error to be 0.7.
0.7 is our margin of error, equals. Now his question was, should we do the positive or the negative? Go ahead and put a plus or minus for that 1.645. What else do we know?
Well, we know sigma, right?
Got it right there. So we plug that in. And now divided by what's n?
I don't know. Where is n?
There is no n. That is what we are trying to solve for. So you're going to divide that by square root of n. And now the question is, how do I solve that?
So the first thing you need to do is if you multiply both sides by the square root of n, you notice that the square root of n cancels on the right-hand side. Okay? And then you can divide both sides by 0.7. And the 0.7s cancel on this side. Okay? So if you want to rewrite that, square root of n equals the plus or minus 1.645 times 15 divided by 0.7. Okay? Now, how do we get rid of a square root?
We do a square root.
No. You have to square to get rid of a square root. Okay. So if you square this side, you have to square the other side.
That?
Exactly. Now, what happens when you square a negative number?
I didn't. I'm only squaring the 0.7.
No, you need to square the whole thing. It's very, very confusing.
Like that?
You got to square. You squared the whole side here. You got to square the whole side over there.
Okay.
So now what happens when you square a negative number?
It goes positive.
So what does that matter for this problem?
Well, let me try it using a positive. If I put in 1.645 times 15 over 0.7 and then square the whole thing, I get 1,242.56.
1,242.6.
0.6. Now, watch what happens if I try using a negative. Oh, I get the same thing.
How does that happen? That's magic.
Because this negative squared makes a positive. As such, it doesn't matter whether you use the positive or the negative z, you're going to get the same answer.
Okay. So is this 1,242.6 my final answer?
Well, you can't survey 0.6 of a person. So, should we round it?
So we should absolutely round it because we can't survey 0.6 of a person. The question be, should we round it up or should we round it down? Now, because we want to get a margin of error of this 0.7, if we round it down, we won't achieve that perfectly. So we're going to round it up to be a little more conservative. So your final answer is going to be 1,243.
1,243. What if our answer here was 1,242.0001?
Then you would still round up to 1,243. You always round up when you're trying to figure out a sample size.
Got it.